a little bit about specific heat, what it means, and some calculations involving it. So let's say you're cooking some pasta at home, and you're cooking it in a pot and you want to stir it. Well, there's a certain sort of spoon that you probably use. You probably wouldn't use an aluminum spoon or a copper spoon or an iron spoon. You'd probably use a wooden spoon, perhaps a plastic one. Now, you could ask yourself, well, why is that? Why do I use a wooden one? Well, in general terms, I think everybody knows you use one because the wood doesn't heat up as quickly. And the reason for that is something to do with a concept called specific heat. Specific heat talks about how much energy, in this case in joules, does it take to raise 1 gram of a substance by 1 degree C. So when we look at copper, what this says is for copper it takes 0.38 joules of energy to raise 1 gram of copper 1 degree C. It takes aluminum more than twice as much energy. So aluminum requires 0.897 joules of energy to raise 1 gram of it by 1 degree C. Wood is even higher than that. In order to heat up a sample of wood by 1 degree C and 1 gram of it, you've got to put in much more energy. So what this means is a low value for specific heat means it's something that heats up really quickly. A higher value for the wood here is something that heats up not so quickly at all. And that's why you use wood to heat to stir your pasta, because it just doesn't heat up very much. It's also why you see plastic and wooden handles on cookware. It's just safer. All right. Now, of course, the really expensive pans have metal handles, and you see the chefs holding those with the rags and stuff. Well, you know, that's just more expensive. That's just the way it is. Anyway, let's talk about a calculation involving specific heat. Anytime you're talking about specific heat, there's an equation that's really important to remember. The heat here is the heat involved in whatever process you are talking about. And that is equal to the mass of whatever is absorbing the heat, usually water or metal or something like that, times by the temperature change from the highest temperature to the lowest temperature. How much did it go up? And SH is the specific heat. Every single element, just as we saw here, has its different unique value for specific heat. Different things absorb heat at different rates. It's as simple as that. You'll notice that when you get things out of the dryer, after it's just gone off, some things are really hot to the touch, some things are not so hot. They have different specific heats and they just feel less hot, more hot. So this is a really important 4-component equation to know. Heat involved is equal to mass times temperature change times specific heat. Now let's talk units here for just a minute. The units of specific heat are some form of energy per gram per degree C, joules, calories, something like that. We're going to stick with joules for now. If these are the units of specific heat, joules per gram per degree C, notice degrees C and grams are on the bottom, joules is on the top. Temperature is usually shown in degrees C, and so if we have degrees C on the top there, and then for the mass it's going to be in grams. Notice we got grams and degrees C on the top, grams and degrees C on the bottom here, so those all cancel out. So the question then is, when using this equation, what's the unit for the heat that you get out? Of course, it's going to be joules. We may convert that to calories or kilocalories or something else later on. Not much of an issue. So, here's a question. It says 5 kilograms of water is heated from 22 to 28 degrees C. How many kilocalories of energy, or how many kilocalories are absorbed by the water? So this means we have to use this equation. Alright, it's asking us how many kilocalories this should say of heat or energy are being absorbed by the water. So we're looking for amount of heat. So we're looking for this. If we're looking for this, then we must have this, this, and this. So let's see what we have. We have 5 kilograms of water, so we have a mass of the water. Obviously kilograms isn't grams, but we can convert that. We have a temperature, initial and final temperature. It's heated from 22 to 28 degrees, so that's the final temperature. That's the initial, so you can see what the temperature difference is. And then we have the specific heat, or we need the specific heat of water. Well, it's got two values here. 4.18 joules per gram per degree C, or 1.00 calories per gram per degree C. Now, given that we want to figure this out in kilocalories, there's a very simple relationship between calories and kilocalories. In fact, it's right here. We don't need to worry about joules, so we're going to use this number. So we're going to write out our equation. The heat involved in the process here is equal to the mass, in this case of the water, times the temperature change that the water is involved in, times the specific heat of the water. Now, 5 kilograms of water, I'm sure you guys remember, 1,000 grams in a kilogram, so therefore 5,000 grams of water is our mass. Now, our delta T is the final minus the initial. Anytime you have change, delta here is change, that's what this symbol is. It's always final minus initial, so 28 minus 22 is of course 6. And I'm going to put the units in here, 6 degrees C. Now, the specific heat of the water is given to us there, it's 1.00 calories per gram per degree C. Now let's just look at our units here. We're being asked for an amount of heat, which means that our final unit's got to be joules or calories or something like that. So that means all our other units must cancel out. Well, grams on the bottom, grams on top. Degree C on the top, degree C on the bottom. 5,000 times 6 times 1 is 30,000 calories. But the question doesn't ask us for calories, it asks for kilocalories. So if we have 30,000 calories, and we have our conversion factor here of 1 kilocalorie is 1,000 calories, I'm sure you can figure out here that the final answer is 30 kilocalories. Now, our number here was originally in 2 significant figures, so we've got to show this to 2 significant figures too, so we put a decimal point there. That is our answer. That's how we use this equation. And the nice thing about this is, you notice there are 4 variables here, 1, 2, 3, and 4. You have to know 3 of the variables to calculate the 4th. So you could see questions that ask to calculate heat. You could see questions that ask to calculate specific heat, temperature change, or mass. Provided you give them the other 3, there is no issue. Let's just do an example of that. This question is asking you to find a specific heat, so it's asking you to find this guy. Alright? And if you're asked to find this, then you must be given this, this, and this. Alright? It says calculate the specific heat of 13.5 grams of zinc, which is heated from 24.2 to 83.6 degrees. It absorbs 312 joules of heat whilst it's being heated. Okay? So let's write out our equation. So heat, as we saw before, is equal to the mass of whatever's absorbing the heat, in this case our zinc, times our temperature change, which we can calculate, times our specific heat. Alright? Now, let's start off with the heat. How much heat are we talking about? Well, our heat is right here. It absorbs 312 joules of heat, so our heat must be 312 joules. The mass of our zinc is actually given to us right there. It's 13.5 grams. Our temperature change is going to be our final minus our initial, so 83.6 minus 24.2. I think that's going to be 83.6. Bollocks, I should have figured this out before I started making this video. Alright, anyway, if that was 23.2, that would be 60, so I think this is going to be 59.4 degrees C. I hope that's right. Anyway, so that's our temperature change, 59.4 degrees C. Specific heat is what we're looking to find. Alright? Okay. So can everybody see this and this and this we have? And now specifically we have our specific heat here. A simple way to rearrange the equation is just to say that if we take specific heat and we want it on its own, then we've got to divide by both of these. So therefore our specific heat is going to be equal to 312 joules divided by 13.5 grams times 59.4 degrees C. Now before you do anything else, take a look at the units that you're going to get. We're going to have joules per gram per degree C, which is exactly the unit that we said we want specific heat to be in. So we know we're on the right track. Now it's just a case of getting out our calculator, which I should have done before. So 13.5 grams times 59.4 degrees C. I always like to make sure and allow for as little error as possible, so those two numbers multiplied together are 801.9. So therefore my specific heat is going to be 312 divided by 801.9, so 312 divided by 801.9 gives me a specific heat of 0.389 joules per gram per degree C. I was given 3 significant figures here, and 3 here, and 3 here, and 3 here, so therefore the answer is going to be shown to 3 significant figures. Alright, so as I said before, provided you have 3 of these 4 variables, you can calculate the fourth, no matter what you're looking for. And that's the way it goes. That's pretty much it. Thank you.